What's up, Ketchup? Hey, it's Mr. O again, and what if you are a FedEx guy and you have to deliver like 6 to 7 houses for one day, and you need to come up with the best route in order for you to maximize your time and minimize your cost of fuel and the time that you can spend traveling, assuming that all these houses are in different place. That's you, and this is the FedEx, and you're gonna deliver those packages to those different houses. How are you gonna maximize your situation by minimizing the cost and the time? This is the kind of problem that linear programming will help us to resolve it. Okay, so today we're gonna do linear programming. Okay? What's linear programming? In linear programming, this is a program that will help us to understand in any business, in any situation, can help us to minimize or maximize our profit or minimize our expenses. If we talk about business, could be in time, minimizing the time if we're making sure that we save more, and so on and so forth. In this topic, we can use logic in the topic of a system of linear equation or inequalities, which we have learned from the past chapter. So we can review by starting graphing the system by y greater than 3x minus 1, which we all know that is -1 right here. And the slope there is 3. The slope of this equation is 3. 1, 2, 3 over 1. And that is going to be dotted line. And since that's greater than, we shade above, the above portion of this line is somewhere here in this pink area. And for the 3x minus 2y greater than or equal to -4, so you have to solve for the y here by subtracting 3x, subtract 3x, -2y greater than -3x minus 4. We're going to divide by -2, -2, -2. That gives a y. You have to flip it because we divide by negative. We have x plus 2. That means we start at 2 and up 3, 1, 2, 3 over 2. 1, 2, 3 over 1, 2, 3 over 2. And down 1, 2, 3 over 2 to the left. And since there's a line there, it's going to be a solid line. Since below, they're gonna graph the yellow portion. In this case, the solution is where the yellow and the pink overlap, which is somewhere right here. And we can say that's our feasible region. Feasible region is where the possible answers that we can get to apply in linear programming. So there you go. Okay, let's look at this one here. The shaded portion where the solution is where we're going to have our feasible region. That's the possible answer. Where the point of intersection is our vertices. And the constraints are our lines, based on our system. There's a possibility that our feasible region is not bounded. Here is bounded because the shaded area is contained, and unlike here, it's infinitely going this side, so it's unbounded. So let's look at this problem here. Find the minimum value of them and the maximum value of the C of x of y, given that x plus 5y, subject to the following constraint. First, if x greater than 2. X greater than 2, we graph that one at the 2, solid line. And this green one here, x greater than or equal to 2, is going to the left or right? This is going to the right. So we can highlight the green one here. Next, the pink one. X is less than or equal to 5. The 5 is right here. And that's pointing to the left, so the graph is going to the left here. But to save you some time, since you know that the green and the pink did not overlap on this side, you don't really have to graph this portion. So I can just simply highlight this area where the green and pink overlap to save and to make it neat and plain. Okay, and then there's another one here, the y greater than 0. Y greater than 0 is everything on the above the x-axis. So we know that the graph is this line, this gold line here, and everything above it. Again, I can highlight this portion, but I don't need it. I don't need it either here. So I only need this portion here. And the last one here is the another constraint, which is y less than or equal to negative 2x plus 12, which you start at 12, somewhere here probably, 11, 12, let's say there's a 12 there. And the slope is down 2 over 1, down 2 over 1, down 2 over 1. There you go. And that's a solid line again. And we have to shade the bottom part because it's less than. So let's shade the red one. Again, I don't have to shade this portion here because there's no common area or feasible region is out there. It's somewhere here in the shaded portion. So I'm gonna shade this one here. If you notice that the points are only, or the visible region is only on the white one. Where's the white one? This portion here. There you go. So that's how you get or find your visible region. Now, how do you find the points? Okay, how do you find this point here? Okay, so this equation here is x equals 2. This line here is x equals 2, and this line here is y is equal to negative 2x plus 12 based from here. Is the intersection of the red and the green. So what you need to do there is that if the meaning of this one is x equals 2, you will plug in the 2 right there on this equation. So that will give you y is equal to negative 2 times 2 plus 12, which will give you y is equal to negative 4 plus 12. Therefore, y is equal to 8. So that means the point of intersection right here is 2, 8. That is your first vertex. This point here is obviously what? The value of gold there, y is equal to 0. And the value of the green line there, which you can't see it anywhere, it's the first green line, is x equals 2. So what is this point? That will be 2, 0. And for this one here, this point here, you know that is the y equals 5, x equals 5, this one here. So that will be a 5. And since it's also along the x-axis, it will be 5, 0. So now, hold on, down 2, 1, down 2, 1, down 2, 1. There's another point here, okay? It's really important that you graph them precisely in a graph paper so you can see the actual points. Okay, I couldn't just see it clearly here, but there should be another point right here, this yellow point here. And how do I get that one? Since I know that this line here is the x equals 5, and this line here is the negative 2x plus 12, so I can plug in the 5 to the x here. That will give me y is equal to negative 2 times 5 plus 12. So that will give you y equals negative 10 plus 12, or y equals 2. So therefore the yellow point here is 5, 2. Okay, so what are our vertices now? Our vertices here came out to be vertex 2, 8, 2, 0, 5, 2, and 5, 0. Now, the question out here is, how do we know the minimum and the maximum among these 4 vertices? what we need to do here is to plug in, hold on. What we need to do here is we plug in the vertices on our function c of xy equals x plus 5y. So since the given function x plus 5y, you're gonna plug in the x value here, which is 2, and a to the y here. So that will give you 2 plus 5 times 8, which 2 plus 5 times 8 is going to give you 42. 2 times 0 will give you 2 plus 5 times 0, which will give you 2. 5 plus 5 times 2 will give you 15. And 5 times 0 is 5 plus 5 times 0 will give you just 5. With these values here that we got, we can see that 2 is the smallest one and 42 is the highest one. What's the meaning of that? This 2 here is our minimum. And this 42 is our maximum value. But how do you get the maximum value? Maximum value at 2.8, minimum value at 2.0. Okay, from here I'll stop. I'll explain more once we meet again tomorrow. Okay, have a good day. Bye.